Let us try to look at the range of this function a cos theta plus b sin theta plus c. Remember, it's an important module because a lot of students get confused here. I can write this as f of theta. F of theta is your a cos theta plus b sin theta plus c. Right, you have a constant here and you have two terms which take theta as your input. So if you give theta to your theta inputs to this, you get f of theta as your output. Like this entire thing will give you the output and I'm assigning that to f of theta. Now I want to see for all values of theta, what are the maximum and the minimum possible values? Because there's something that we already know, that my sin theta lies between -1 and 1. My cos theta also lies between -1 and 1. No matter how big the value of theta I give, these two functions will lie between -1 and 1, right? So if I keep giving bigger and bigger theta, that doesn't mean that I'll keep getting bigger and bigger value, because this constant is fixed, and these two terms which take theta as the input, they are also bound between -1 and 1. So that's obvious that this f of theta is also bound between some values. So what are those values? What is the minimum value? What is the maximum value? That is what we are going to look at. So let this be your function. Remember, whenever you come across something like this, whenever you come across something like a cos theta plus b sin theta, you need to divide with under root a square plus b square, under root a square plus b square, and you need to multiply it with that. Remember, this is a very, very crucial step. Whenever you look at this function, whenever you look at something like this, you need to check a, check b, whatever it is, and then divide with the square root of the sum of these two. It's a very, very important trick. It's used in a lot of places, not just in maths, in physics as well, right? So under root a square plus b square, you multiply and divide. So I multiplied it and multiply with under root a square plus b square, and I've divided. Let me see why I did that. The constant is lying as it is, right? The c is lying as it is. So I let my under root a by under root a square plus b square equal to sin alpha. I can do that because this quantity is less than 1, right? A by under root a square plus b square is obviously less than 1 because a by under root a square is 1, and if I further divide it with under root a square divided with some b square, it will obviously be less than 1, right? Or at least it can't be greater than 1. Even if it's equal to 1, it's fine. I can still assign it to sin alpha, right? And if this is sin alpha, then this term will automatically be, the other term will automatically be cos alpha. Why? Because you square these two, you square cos square alpha plus sin square alpha, you have to get a 1, right? So sin square alpha is this, cos square alpha will be 1 minus a square by a square plus b square. So from that you'll get your cos alpha will automatically be this, right? If sin alpha is this, cos alpha is this, then tan alpha will be a by b. So now this is my sin alpha, this is my cos alpha. So under root a square plus b square is still there as it is. This I can change to sin alpha, this I can change to cos alpha because that's what I've assumed. So this is sin alpha cos theta plus cos alpha sin theta form. So sin alpha plus theta, right? Sin a plus b formula that you have seen before. I've just used that. So I hope you understood why I divided and multiplied with under root a square plus b square now, because I wanted to convert this part. I wanted to convert this part to this form, right? Whenever you have to convert things like these to things like sin alpha plus theta or cos alpha plus theta, you always do this step, this important step that I was talking about, right? So now you have this function. So this is your f of theta, right? So the same thing is now reduced to this. So sin alpha plus theta is sine of some angle, whatever that angle is. Sine of anything always lies between -1 and 1, right? And now if I can multiply with under root a square plus b square, so under root a square plus b square sin alpha plus theta, and this is less than under root a square plus b square. I just multiply with under root a square plus b square on all sides, right? And I can add c, so plus c plus c plus c. So as you can see, this is your f of theta. So f of theta, this is c minus under root a square plus b square, and this is c plus under root a square plus b square. So this is your final inequality that you need to keep in mind. This is the final inequality that you need to keep in mind. So if this is your f of theta, a cos theta plus b sin theta plus c, then your f of theta will always belong to closed bracket c minus under root a square plus b square, comma c plus under root a square plus b square. This step itself means, this thing itself means this, like f of theta will always lie between these two values. It can take anything from here to here, including these two, and everything else in the middle, right? So this is something that you need to keep in mind, the formula for this range, and also this particular step this particular step that you just looked at, it's very, very important. Whenever you come across something like this, a cos theta plus b sin theta, always try to reduce it to this form using this step. So just keep looking at this again and again and derive it once yourself. You'll be able to understand it much better. The final result that you need to keep in mind from this module is this. Let's move on to the next subtopic.